Hello, everybody. Hopefully by now you're fairly familiar with the idea of finding a volume of revolution, and we did that by looking at how we would rotate a disk around an x-axis in the last section. But that's not the only way to find a volume of revolution. Another one would be if we were to take something like a strip, a dx width strip, let's say under the curve y equals f of x, and rotate it about the y-axis, creating a shell, creating what would look like the outside of a can, right, with some sort of thickness right there. How would we find the volume of that thickness? Well, maybe the best visualization would be the following. Think about taking that shell and we just detach it right here in the middle and spread it out. What would be its dimensions? Well, we remember that the circumference in a circular disc is kind of goes like this. We have a radius, right? So if we have a certain radius for this cam, we're going to say, well, the circumference is equal to 2 pi times r, right? That is our circumference of our shell. It will have a thickness, right? We might call that h at least for the moment. And it will have a height. But what is that height? Well, that height right here, uh, let's call that height f, right? So what are we going to do? Well, our circumference, right, our dimensions of this plate that we get from unrolling this shell is going to be uh, a volume of 2 pi r, the radius, times f, which is the height, right? So it's a width times a height times the thickness, h. Only in this case, where are we getting these values? Well, in this case, we're getting these values under this entire region by taking a collection of these guys right here, taking a sum of all of the shells that we would build up by moving each piece one by one, right, and counting up all of these things. So how do we get that? Well, let's work on this shell volume right here again. In this case, if we're going about the x-axis, instead of a radius, right, we're going to let our radius be replaced with the value x, right, because x is the distance from the y-axis to whatever x value we're talking about right here. For the height, of course, we have our function f of x. Right, so that's our function, h equals f of x. For the thickness of our plate, of course, we're going to call it dx. So thickness is going to be dx, right? And so when we put together a formula right here, we could think that, okay, if we're going to get each one of these I rectangles right here of delta x, we can think of it kind of like a Riemann sum again. We're going to take the sum of all of those uh, dx or delta x thickness shells right here. We're going to add them up. So from I equals 1 to n, whatever n is, it will be 2 pi r, right, for our circumference. So 2 pi x right here. And for each one, we have a specific x of I. 2 pi x of I times f of x of I, right? So that's the height of each one of those shells times the thickness of those plates. And here's the thing, if we take the limit of that as n goes to infinity, well, sure enough, we're going to get some shells that say if we go from a to b over this interval, we'll take 2 pi times x, that's our radius, times f of x dx. Right? And that would give us this volume by rotation. So let's try some examples here in the next video.